See if I can write with this. All right. So in this kind of problem, you're going to multiply your diagonals, right? So 2 times 3x plus minus 2. 2 times 3x minus 2 equals, and then x times 5. X times 5. So 6x minus 4 equals 5x. Subtract the 5x from both sides. Add the 4 to both sides. So I get x equals 4. Now I want the whole length from k to z. So I want that whole length from k to z. So I need 2 plus 3 times 4 minus 2. 2 plus 12 minus 2. 2 plus 12 minus 2 is going to be 12. The most popular wrong answer is 10 because you just substituted into this part and forget about that little piece between K and L. So you want to definitely be sure that you're finding the right question, right? There we go. Here in Desmos, right, you want to just put all, and there's a couple ways to do this. You can use 100% Desmos. So x minus 1 squared plus y minus 3 squared, and then equals, and it's asking us which of these things is the radius. So I'm going to go ahead and put my blank parentheses and squared in because I know I need whatever this is needs to be squared. And then I want it to hit the point 4, 7. If I put in 4, 7, we can do that. And then I need to come over here so I can see my equation, right? So I want my circle to go through that dot. So if I put in the square root of 13, that doesn't go through the dot. So I know it's not A. If I put in 5, oops, 5, ooh, it goes through there. So 5 looks like a good answer choice. If I put in 5 and then the square root of 5, that's too big. The trick here is these parentheses, right? I can also take this out and put in the 137, and that doesn't go through either. Now, we know that the right answer is 5. If you do this and you don't put those parentheses in, look what happens. Because the order of operations is different here, it's squaring the square root of 5 and then multiplying by 5. So when you do this method, you 100% need to have those in parentheses. So the correct answer is 5. The other way to do this, and I'll show you on the next slide, maybe. So we established that the correct answer is 5 using Desmos and making sure we put the radius squared in, right? But I have an X and I have a Y, and I was super happy to see a lot of people substituted. So if I put my 4 in here, 4 minus 1 squared, plus, and I put my Y in here, 7 minus 3 squared equals R squared. I can use algebra and just solve the equation. So 4 minus 1 is 3, and 7 minus 3 is 4. So that's 9 plus 16 equals R squared, or 25 equals R squared. So R must equal 5. So you can either put it in Desmos. If you put it in Desmos, make sure you put parentheses around your radii, right, that you're testing. Or if you're given a point, just substitute. Either way is going to work. How we feel about that? See if I can move this toolbar. I don't think so. All right. So what about this? How do am I finding the area or the circumference? Area or circumference? says area. So my area formula is pi r squared. I'm going to do my angle. So 80 over 360 times the area. So pi, and then the radius is 13 squared. When you put all that in the calculator, what do you get? Anybody? I did something crazy, I think. I didn't do divided by 360. Anybody get 118? Somehow I don't have my chat. This is a problem.
I got 118.
Awesome. My tools are hiding on top of each other today. So in Desmos, right, when I do it in the Pear Deck, it saves everything here. So you can type these in if you're not quite sure and just change out whatever's in your Desmo, right? Or we can come over here and just look at the pattern. So if I want to circle center at +4, -7, I need a -4 in the equation, right? So it can't be the -7, and it has to be squared because I know the pattern. And then because I have a -7, I need a +7 over here. So it's not going to be either one of those, and I need it to be squared. Okay. And then if the radius is 4, remember the end of our equation is always squared as well. So that's going to be 4 squared. If you're not sure what symbol goes in the middle, you will have access to a formula sheet. So this is a copy of the formula sheet. I don't think I've shown it to you before. And on the second page of it is your equation. Okay, there's your equation of a circle. That's also almost the distance formula. X minus x squared plus y minus y squared. Do you see the similarities there? So if we come back over here, we definitely need a plus. Questions on that one? Pretty easy, I think. So this one, same thing, but it has some distractors in it. Okay, so this one has some information that you don't need. You've got to be smarter than the question writer. The minute hand on the clock is 10 centimeters long. So the minute hand is this one. This is 10 centimeters, right? And it travels of an arc of 108 degrees every 18 minutes. The 18 minutes is the distractor. You don't need that number. Which measure is closest to the length of the arc? So anytime I see length of the arc, I automatically think degrees over 360 times circumference. Here's my chat. It's amazing when it appears and when it goes away. Wish I understood why. Good morning, Michael. We're reviewing the warm-up. I just put it in the chat for you. So my radius is going to be 10 centimeters. So I'm going to come over here and my angle is going to be 108. So 108 divided by 360 times 2 pi 10. I know that's hard to read. That's the 10 centimeters, right? So a lot of things that you need to know in this problem in order to be able to translate it into math. And that's 100% the hard part about this problem. When you do all of that math in your calculator, what number do you get? Anybody got that? You can also kind of look at it reasonably. This arc looks like it's longer than the radius, so it's probably going to be bigger than 10. When you put it in the calculator, you get 18.8. It is bigger than 10. All right, for these questions, I would 100% just put this into the calculator. So you get a question like this and it says what point lies on it. You can substitute like we did before, or you can put it into Desmos, right? Equals 7 squared, and then put all your points. -1, 4, and 0, 7, and 1, 3, and 8, 3. And if you're not sure which one is which, even though they're all different colors, you can click on that label tool and you can tell exactly which one is your answer choice. So which one should I choose? Everybody says 8, 3. So over here, we want to do 8, 3. Sound good? All right. How do I write the equation if I have the center and the radius? So I want to put in a -4, but instead of a -4, I need a +4. Remember, those are backwards. Instead of a +6 for the y, I need a -6 for the y. And then remember that the radius is always squared. So instead of 7 squared, I need 10 squared. And then put in all your ordered pairs, just like we did with the last one. It's not cheating using Desmos, it's using your tools wisely. So make sure you use your tools wisely. It's just another calculator. 6, 16, boom. And if you're not sure which one is which, you can go back and click the label button and it'll tell you exactly which one is which. Saves you a little time in graphing. So I want that black one, that 4, 0. So my answer is going to be C. Questions on that, guys? Was that the last question or is there one more? That looks like it was the last question. Only 3 more of these. Stick with it. We're almost done. I know it's death by Pear Deck. Death by Pear Deck. All right. The next thing I wanted to talk to you guys about was that quiz. So how did we feel about the quiz yesterday? Any thoughts? Lots of people opened it. Not very many people submitted it. So I know how people did based on the submissions, but I need you to talk to me about what we need to talk about because we can't go through all 20 questions this morning. If I'm looking for the measure of BCD, I want to go from B to C to D. That's all of this space that's not marked. Right? So if the circle equals 360 in total, I can take the total minus the 2 parts that I know. It's going to give me what's left. B, C, D. So take a minute, grab your calculators, open the quiz from last night's homework, do 360 minus 30 minus 35, and see what you get. A brain dump. Yikes. Any questions on number 1? It's pretty easy once you translate the question. I think the most missed answer is 65. It is not 65 because you're not going from B to A to D. You're going from B to C to D. So you definitely have to read that question carefully. If the circumference of a circle is, right? So I can translate this, C equals 244 pi. What is the length of the diameter? Well, if we go to our formula sheet, we can go to maybe the first page. And on the first page, we've got some formulas, right? 2 of them relate circumference. So pi r squared and pi d. So I'm going to come back to my quiz and put pi r, 2 pi r or pi d. If I want the diameter, I'm going to use this one, right? So if 244 pi equals pi d, then I divide by pi to get rid of the pi's and divide by pi and get rid of the pi's. And what's left is 244 equals the diameter. And that's it. This is one of the easiest questions that is overthought, ladies and gentlemen. You just got to remember that the circumference is just pi times the diameter. So if you're given the circumference equals a number times pi, diameter is just that number. Okay. Excellent job on this one, everybody who did it. So if you go back to that formula sheet, you'll see area of a circle equals pi r squared. The hard part here is to just remember that the radius is half of the diameter. So the radius is going to be 5.7, right? Use that and you'll get the right answer every time. Question number 4, the circumference of a circle is what I want to find, and the area is what I'm given. So props to everybody who got this one right. This is a tough question, right? Or at least it has some, you got to go through some steps. If I know the area equals pi r squared, and I know that equals 283.53, I want to divide by pi because I want to get the r by itself. So r squared is going to equal, drum roll please, 283.53 divided by 3.14. It's going to equal 90.29. Then next step is to take the square root, because I still want to get r by itself. We're just solving this equation. And then 90.29 is going to give me 9.5. Once you use the area to solve for the radius, you just put it back into the circumference formula. So 2 times pi times the radius, 9.5, should give us the circumference. So step number 1 is to use the area to find the radius. And then step number 2 is use the circumference, or use the radius to find the circumference. Questions on that? Okay, I need you guys to talk to me. Find the measure of arc QT. So arc QT is here. And it is being, think of this as the flashlight problems. So the flashlight is at S and it's shining this direction. The S is small and QT is big. How much bigger is QT than angle S, the small angle? It's twice as big. So I need to multiply by 2. Okay, so if this angle is 65, this arc is 2 times 65. And that's inscribed angles, ladies and gentlemen. Inscribed angles, the angle is half the size of the arc. Let's see if I can get a different color. So if I'm looking for measure of angle STR, STR is this angle, right? So now I'm looking for the small thing, and the big thing is up here. So if the arc is big, that's the 2x. This is the 1x. So I want to divide the big thing by 2 in order to get the small thing. If the arc is 30, then the angle is going to be 15. Does that make sense? So the arcs are twice as big as the angle. If you have the small angle, you want to multiply by 2. If you have the big arc, you want to divide by 2. Questions on that? Nobody got that one right, so I want to make sure everybody understands. Message me in the chat or unmute yourself if you need to, want to. Okay. Kind of a similar thing for question 6, but question 6 is more like question 1. These are all central angles, so the arcs and the angles are going to be exactly the same. If I'm looking for arc BD, I want to go the most direct route from B to D, okay? The most direct route is past C. So if I go from B past C to D, if this angle is 47, then this arc is going to be 47. If this angle is right, what's the measure of this arc from D to C? How big is a right angle? I know you're at home saying to yourself 90 degrees. You're just not brave enough to say it out loud. So if I want to go from B to C, that's 47, and then C to D, that's 90. So if I bypass C altogether and go straight from B all the way to D, that's just going to be whatever 47 plus 90 is. Questions? I'm looking at the chat. So with that in mind, how can I solve for X here? Do we see any diameters? I always look for diameters when I have questions like this. And I see a diameter right here. It's not the only one, but it's definitely the easiest one. The diameter cuts the circle in half. So how many degrees are there in a semicircle? A whole circle is 3. Did you say 180? A whole circle is 360. So a semicircle is going to be 180. So my equation is going to be 180 equals 3x plus 10 plus 65. The key is to look for those diameters. They're really important. And then we just solve that equation. We all good on solving equations like that? Do I need to review it? Okay. Question number 8 is another inscribed angle. We've got a small angle and a big arc. The trick here is to translate, and it is a trick until you get used to it. So angle, that's measure of angle BCD. So this angle right here, BCD, is that 4x minus 50. And that is the small thing. The angles are small. Then the measure of arc, BAD, from B all the way past A and all the way to D, right? That whole big arc is 105 plus 3x. So if this thing is the big thing, I need to multiply the small thing by 2 in order to make them equal, right? So my equation is going to be 2 times the small thing equals the big thing. And then you have to distribute. So 4x times 2x is 8x, and 2 times minus 50 is minus 100, and then 105 plus 3x. I always move my smaller x's, which means I need to move the numbers to the other side. So 5x equals 205, and then divide. So divide by 5 and divide by 5. X equals, is that 41? I need to go to my calculator and make sure. Sometimes I do weird things when I do things in my head. 41. The problem is that's not my final answer. Why is that not my final answer? What's the question asking for? Arc BAD. So I got to go back to that arc BAD and put in my 41. So 105 plus 3 times 41. 105 plus 3 times 41. Did you get 228? Nice, Nasia. And that is in degrees. Arcs are measured in degrees. Sweet. All right. I was surprised this one was 50%. We're looking for the area, so we're going to use pi r squared, right? It's already shaded. There's nothing tricky about this. 130 divided by 360 times the area, and I know my r is 5. Just put all that in the calculator, and it's pretty straightforward. The problem sometimes arises by using circumference here instead of area. You want to make sure you read the question carefully. Do we need to spend any more time on that one? I can't teach alone. I need you to give me feedback. All right. This one is the same. It just changes it up just slightly. Don't overthink it is my suggestion here. So I still want my arc, right? I want the length, so I'm going to use circumference. So 120 over 360, just like the hypotenuse and trig, the 360 always goes to the bottom. And then I remember multiplying by the circumference. So if I know the circumference is 216 pi, there's no math involved here, ladies and gentlemen. Don't overthink this. You're multiplying by the circumference. So all you do is do 120 divided by 360 times 216 pi. All of my answer choices have pi in them. So when I put this in the calculator, I don't put the pi. I'm just going to put in 120 divided by 360 times 216. Put that in your calculator and you should have the answer. If there's pi in your answer choice, you do not need to put it in the calculator. Okay. 100%, yay! There's no x here, so we're looking for RB. That is our variable. That is what we're looking for. Multiply your two pieces together. So 2 times x equals 3 times 5, and you should get your answer. Nice work on that one. This is the exact same question. It's just a little more complicated, right? So I think, in fact, this was our exact one that we did in the warm-up this morning. And then 5x. So we got 6x minus 4 equals 5x. So if I subtract my smaller variable and at the same time move my numbers to the other side, my x's cross out, my constants cross out, and x equals 4. The problem was we were looking for kz. So kz is this whole distance across, right? We can't forget about that little 2. So I need 2 plus 3 times 4 minus 2. And what was our answer there, everybody? 12. Perfect. This is what we learned yesterday. What was the formula we needed to remember yesterday? What do we do with these? Can anybody unmute themselves or put it in the chat? What do we have to set equal?
Outside times total.
Absolutely. Outside times the total equals the outside times the total. And this is brand new. We just learned it yesterday. So 5 times 5 plus 12 equals 6 times 6 plus x. You can put this whole thing in the calculator exactly the way you see it. 5 parentheses 5 plus 12, close the parentheses, and I get 85. So 85 equals 6 times 6 is 36, and 6 times x is 6x. So I'm going to do 85 minus 36 and get 49. I'm already kind of looking like, did I do something weird? Because I know that 49 divided by 6 is going to give me a decimal. But let's go ahead and see. I just checked my answer choices, and lo and behold, there is an answer choice. It needs to be rounded, right? But it says round to the nearest tenth if necessary, so I'm allowed to round. Questions on that one? Outside times the total equals outside times the total. Find the value of x, round to the nearest tenth if necessary. So we're going to do the exact same thing. Outside times the total, it's just that that's the same. So x squared equals, and then outside times the total. 6 times 6 plus 9. Even though we got 100% on this, I'm going over it just because I want to make sure that we know it, right? So all of that goes in the calculator, 6 parentheses, 6 plus 9, close parentheses, and we get 90. X squared equals 90. And what do I do for my final step? Take the square root. Loving it. Easy peasy lemon squeezy. Good morning, Alexis. We're on the quiz from yesterday. So we're in the January 13th folder on question number 14. All right, this is my favorite kind of question, the ice cream cone question. I might actually have to go get some ice cream later today, even though I'm so freezing cold. So what do I do with the 9x minus 7 and the 29? Set them. Hopefully you're all saying equal to each other. This is symmetrical, right? I could make a straight line of symmetry through here and fold that shape in half. Again, if it looks symmetrical in circles, it probably is. There are like literally a dozen circle formulas. We're only teaching you about half of them. So you could see something on the SOL or the district exam that I have not shown you. If it looks symmetrical in circles, it probably is. They don't 100% have to be marked. That's a whole bunch of theorems that we should have been taught, but maybe we didn't get to, right? We're on definitely a time crunch here. So if I do 9x equals 36, right? 36, then x equals 4. Questions on the ice cream cone? Looks like giant mint chocolate chip. I want to put chocolate sprinkles in that. It's my daughter's favorite kind. All right. So with that in mind, right, all my Harry Potter fans, this is like the Deathly Hallows image. We got to mark everything. So AE equals 4. What else equals 4? What's the other side of that ice cream cone?
Or no, EC.
East, is that the other side of the ice cream cone? So if I stick A is the vertex of the ice cream cone and I stick that on the ice cream ball, AE is the right side. What's the other side? Is it over here? That's the other side of the ice cream cone, the other side of the triangle. So those are going to be the same. And then EC is 5. What's the other side of that ice cream cone if I put that one on the bottom?
It'd be DB.
EC and CF. So this is a ice cream cone. See how they're together? So this vertex means that these are the same. And this vertex means that these guys are the same. And then we've got our last one, BF. So BF is this guy. And that's the vertex at B. So BF and BD are going to be the same. So find the corner of the triangle, and those two sides that make the corner are going to be the same. Maybe that's an easier way to look at it. Does that make more sense? So if I have A, I've got 4 on the left and 4 on the right. And if I've got C, I've got 5 on the left and 5 on the right. If I've got B, I've got 6 on the left and 6 on the right. So those are kind of your ice cream cones that go on. And then I want the perimeter. How do I find the perimeter? Hopefully everybody's saying add them up. So 4 plus 4 plus 5 plus 5 plus 6 plus 6 equals, or some of you smarty pants out there are doing 4 plus 5 plus 6 and then multiply by 2, and that's going to be your answer. I think question number 17 is kind of a tough question. If you answered this correctly, how did you do it? If the whole stadium seats 150,000 people, how did you know what this little piece said? Sometimes what I do is I count these little pieces, 1, 2, 3, 4, 5. And then I go 1, 2, 3, 4, 5, and I make a mark. And 1, 2, 3, 4, 5, and I make a mark. 1, 2, 3, 4, 5, and I make a mark. 1, 2, 3, 4, 5, and I make a mark. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces. So if 150 is the total and I've divided it into 8 sections, just 150 divided by 8. And you should get an answer. 150,000 divided by 8. And then it says the closest to the maximum number. So which one is closest? Because it's not exact. Did anybody get an answer? $150,000 divided by 8. All right, hopefully you did. Charles cut a slice from a circular pizza with a diameter shown. So every time it says diameter, I always find the radius. Radius is half of the diameter, so that's going to be 7.5. The slice has an arc length of 21.5 inches. So 21.5 inches is the arc length. What is the approximate measure of the central angle of the slice of pizza? So the angle divided by 360 times arc length is circumference. So pi times 7.5 times 2, I forgot my 2, equals 21.5. That's how I would do it. So the angle is what I'm looking for. Angle divided by 360. I'm going to combine all of these things together. So 2 times 3.14 times 7.5 is 47.1, 21.5. So then I've got to divide that 47, divide by 47.1, divide by 47.1. My handwriting is getting crazy. Let me erase that, make it more clear. $47.1. So now I've got the angle divided by 360 equals 21.5 divided by 47.1. 0.45, which looks crazy until you multiply by 360. Multiply by 360. And then you should get an answer. The other way to do this, I suppose, is to do your equation that we started with and test all your answer choices. So put in the 82, put in the 164, put in the 196, and put in the 278, and then see which one works, right? So either way you want to do it, this math is kind of hard. I was very surprised that we had 100%. My guess is that you just substituted all your answer choices if that's what you did. Okay. Questions on that? This one was another 100% problem. This is just matching. So my circle center is 0, 0, and my radius or my diameter is 8. Here, my circle center is at 5, 3. And my radius is 2. Here, the circle center is at -5, 3. And my radius is 2. And then here, my circle center is 0, 0. And my radius is 2. So you just want to take some time to make sure that you remember that the equation of the circle is backwards. This center is going to be at -5, +3, and have a radius of 2. And this one's going to have a radius of 2. And if it has a diameter of 8, it has a radius of 4. Right? Should be pretty easy. And then the very last question, given the equation, blah, 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 select all the points that are on the circumference. So you can do this algebraically and just put your X and your Y values in and see which one makes it work. Or on your test, you can pull up a Desmo and you can go X plus 7 squared. Oops, I wanted a plus there. And plus y minus 2 squared equals 324. And then I'm going to put in all of my answer choices. 11, comma 2, -7 and 16, 20 and -7. Let Desmos do the heavy lifting for you, right? So here I want -25 and 0. And I can label all of those if it makes me happy. Make that smaller. The 20, -7 is way off, so I want the 11, 2. Definitely. Can't see the rest of my circles, so maybe there's another answer over here. 25 and 0. So 11, 2. And 25 and 0 were my answers. 11, 2, and 25 and 0. Questions on that? I 100% can go back up. Where do I need to go back up to? So for this one, the center is going to be at -5, +3, and have a radius of 2. Because remember, this is r squared. And then this one is going to have a center of 0, 0. This is where the IXL comes in, right? So this is why I pushed the IXL so hard in the last couple of units, because it really does help with the identification. And then if the diameter is 8, the radius is 4. This question is asking you a lot of things about circle equations. Any other questions? Number 5 and 6, okay. The writing software takes a while. It lags, huh? So this was question 6. The trick here was to go from B to D. You want to go all the way from B to D, and you want to go the shortest distance. So you want to go this way. So 47 and 47, and that right angle is 90. So 47 plus 90 for number 6. And then number 5, I think, was a little bit different. This was the big angle and the small angle. So anytime you have an inscribed angle, your angle is half the size of the arc opposite it. So if the angle is 65, you want to multiply by 2 in order to get the arc. The opposite is also true. If you have the arc, you want to divide it by 2 in order to get the angle. Inscribed angles, the angle is small and the arc is big. So go from small to big, multiply by 2. Go from big to small, divide by 2. So number 5 makes sense. And then I see number 8. So let's go to number 8. Number 8 is the same as number 5, so that's a good follow-up question. The angle is small, right? And the arc is big. So my equation was 2 times the small angle equals the big arc. 2 times the small angle equals the big arc. We could have done half of the big thing. So 105 plus 3x divided by 2 equals the small thing. But I think this equation is easier to look at than this one myself. So you can do 2 times the small thing equals the big thing, or half of the big thing equals the small thing. And that only works if your angle touches the outside of the circle. If your angle is on the perimeter of the circle, on the circumference, is the only time that works. Lots of good questions. Any other questions on this? I know it was a lot. I very much appreciate how much work this was. All right, I think that was all good time invested. What I would like to do now, and I don't think I have it open. So just a note, boot camp today is on triangles. So all of that triangle basics that we've been working on in the warm-ups for the last couple of days, triangle inequality, finding the range of the third sides, equilateral triangles, isosceles triangles. We're going to review all of that today if you want to join us in boot camp from 2 to 3. We've got one more tiny little thing to learn about circles, and it has to do with circle angles. So if you meet me on today's folder, the 14th, we'll go to here. For the next 4 days, I do have 2 warm-ups and I'm choosing between them. I chose this first warm-up today. If you want extra practice and you go into this Pear Deck and do this, I will definitely count that for extra credit, but we're not going to review it today. So the link should be open. It should work. What I do want to talk about, though, is exterior angles. So I'm going to give you this Pear Deck in case you are doing it on a separate screen. It is in the chat. And actually, let me open that and see if I made an answer key. Because if I did not make an answer key, we can just do it here. Oh, look at that. I didn't. Perfect. All right. So if you open up that Pear Deck, we're going to talk about exterior angles. So this is kind of going to look a little bit like the ice cream cone thing, right? So the ice cream cone we had on the outside, and we were looking for the sides of the ice cream cone. If I look at angle A, AB and BD of the ice cream cone are going to be the same. Here we're looking to try to find the angles. So I've got a big arc out here and a little arc out here, and then an angle that's tiny. So if I take the big minus the small and then divide by 2, that's going to give me the angle. The big minus the small divided by 2 gives me this angle. The big minus the small divided by 2 gives me the angle. It's that minus sign that messes people up sometimes because we think about averages where we add and then divide by 2. Right? When we do midpoint, we add and divide by 2. Here, when we have arcs, we take the big arc minus the small arc, I want the difference, and then divide that answer by 2. So those are our notes. Let's go look and see if we can come up with some. That's not the size I like. That's the size I like. Let's see if we can do this. So if I've got the big arc, that's the big, that's the small, and then my angle is here. So I'm going to do big minus small, and that's going to be my x, divided by 2 equals the angle, which here is 44. So it's still that formula, big minus small divided by 2 equals the angle. Big minus small divided by 2 equals the angle. So now we just have to solve that. So I'm going to multiply by 2 to get rid of the divide by 2. So 160 minus x equals 88. And then because my x is negative, I'm going to add the x to both sides and subtract the 88. Again, you don't have to do it my way. You can do it your way as long as you get the right answer. X equals 160 minus 88. Oops. 160 minus 88, which is 72. So this orange arc right here is going to equal 72. To check for reasonableness, that pink part should be the big, the orange part should be the medium, and then the blue part should always be the smallest number. So the big part of your arc should be the biggest number, the medium part should be that medium arc, and then the smallest number should be the angle at the vertex. How do we feel about that? So if we set this one up, I'm still going to use that big minus small divided by 2. What's the big? I don't know what that is, but I do know the medium or the small arc. And then I'm looking for PQR. I'm looking for PQR. From P to R, the short way is 131. And if the whole circle is 360, can I do 360 minus 131 equals that question mark? The whole circle is 360, so the short way around is 130. So 360 minus 131 is going to give me 120 or 229. 229. So if I do big minus small, the big is the 229. 229 minus the small arc is 131 divided by 2 gives me my angle, which is x. And now you can do that whole thing in the calculator. 229 minus 131, enter, divided by 2 gives me 49. So x equals 49. And you can check that for reasonableness. As you go from the outside to the inside, they should get smaller. So 229 and then 131 and then 40, that's a 49. Questions on that? I know that was fast. Big minus small divided by 2 in order to find these exterior arcs out here. In order to find these exterior angles, I should say. Okay, so that exterior angle, big minus small divided by 2. Big minus small divided by 2. All right. That is the end of the notes for this unit. There is a quiz test that you may start now, or you can go back and finish the homework in the quiz. So if I go back out into this big circles folder, You've got some tasks that you need to do. There's a homework here that almost everybody has opened, but not everybody has submitted. You've got a quiz here that we just went over. And then you've got a quest here. They're all due by Friday.
Ms. Daughtry,
Yeah.
I have a question.
Yeah.
Would you be able to like